the Institute for Advanced Study in Princeton, New Jersey. Professor Jean Bourgain works here, analyzing and developing mathematical principles.
I'm not an applied mathematician. I am a pure mathematician, so these papers are pure mathematics.
Over the years, he has published papers on a wide range of mathematical fields, from harmonic analysis, nonlinear partial differential equation, combinatorics, the geometry of Banach spaces, to ergodic theory.
There are several things that I liked in math. You can deduce a lot of things from first principles. Just remembering a few things allows you to rebuild a lot of the stuff without having to memorize it. Like formulas, you don't rely much on other people. And you don't rely too much on equipment. I only relied on myself. The field where I have contributed primarily is the area of pseudo-randomness.
Pseudo-randomness is the process of generating random numbers, zeros and ones, the binary bits that make up the language of computers. It has many uses, such as selecting jurors from a given population, compiling statistics, or generating the quote of the day on websites, as well as complex functions such as encrypting secrets to simulating weather patterns. The numbers are pseudo-random because there's a pattern to them, not quite as random as numbers generated from, say, coin flipping.
When people think of random event, they will see someone tossing a coin, and then that, in a way, would produce events that are statistically uncorrelated and are unpredictable. That's another tale. The question is how to produce something that has many features of a truly random coin flipping. And this is where the mathematics comes in, and the so-called pseudo-random number generators.
Slot machines spin an endless combination of symbols. They are programmed by a pseudo-random number generator. The software generates billions of zeros and ones per second that decide who wins or loses. The sequence of numbers repeats itself within a certain period. Conventional mathematical theory states the longer the period before a sequence of numbers repeats itself, the more it seems pseudo-random and less predictable.
Long periods are better. Obviously, if you have short periods, you are in bad shape.
What Bourgain has done is to show, in theory, shorter periods can yield a sequence that seems random as well.
So my contribution was to show, mathematically, that you still have a lot of randomness when this period becomes much smaller.
The linear congruential generator, invented in 1951, is one of the simplest and oldest algorithms. Here, Bourgain shows how it's used to generate numbers. He picks 3 as his base.
What I will do is multiply this number with itself. So you would have 3, then you would have 3 squared, 3 to the third, and so on. How much is 3 to the power 3? This thing is 27.
To generate a pseudo-random number, 27 is divided by a prime number, say 7. The rounded off result, 3, is then multiplied again by the prime to get 21. Add 6 to 21 gives 27. 6 is even, so it's labeled 0. An odd number is designated as 1.
So 3 is 1, 2 is 0, 6 is 0, 4 is 0, 5 is 1, because 5 is odd, 1 is again odd.
If 7 is the prime and 3 the base, 6 is the period. That means after every 6th pseudo-random number is generated, the sequence repeats itself. The period 6 is larger than the square root of the prime number 7. Bourgain's contribution is to justify through this equation the period doesn't have to be large to make numbers more pseudo-random.
problem that was able to solve is justify good statistical properties when the periods are relatively short.
Pseudo-randomness is one of many aspects of Bourgain's work that earned him recognition, including the prestigious Fields Medal in 1994, the Nobel Prize of Mathematics.
I got a Fields Medal at the age of 40 for a collection of works in ergodic theory, differential equations, and also in harmonic analysis. It took me a while just to analyze how I really compare with other possible candidates at that time. I was in fact not really convinced I deserved the prize. It made me work harder and prove myself. We are at the Institute's lake. After work, we like to change the scenery. One of the keys to remain creative. And at some point, you're not productive anymore. You realize your mind is not very sharp. And then you know that you should stop, to try to move to different places. Maybe in town, outside, in a mall, whatever. So see some different faces, different things, and sometimes this is magic.
Jean, aged 56, grew up in a small town in Belgium. He liked maths from an early age.
I would say beginning high school, so age 14, 15. I was a happy child with a normal childhood, nothing like a wonderkind of a precocious child.
He got his PhD from the Free University of Brussels in 1997 and subsequently researched maths in various places before joining the Institute for Advanced Study in 1994. Jean rents this house from the Institute.
Do you often work at home?
In this place, not that much. I may be watching TV and thinking about a math problem. Sometimes I have a little thing to eat.
He lives here for 6 months, and during the summer he moves back to California to be with his wife and 19-year-old son. Mei-Chu Chang from Taiwan is also a mathematician from the University of California, Riverside.
I'm in California. I have a nice office there at home, and I often take the work with me. Of course, there are times they get irritated. For instance, your wife will ask to go shopping. You say, yes, no problem, but just give me 10 minutes, and you continue to work. Then you go out to do the shopping, and you realize that you more or less forgot what they asked you to buy. You buy something else. They are not always that happy. Altogether, I would say that they're giving me an easy time, and they just let me go when they see that I want to have my head somewhere else. IS is a very unusual place, exactly because we have essentially all the freedom to do what we want when we want. It's very stimulating. Also, when you want to discuss a problem, that there are always people around, not too far away, that you can have a conversation with.
Serge Rudnick is a mathematician who has collaborated with Bourgain on several research projects.
I've started to work intensively with him about 2 years ago when I first came to the Institute for Advanced Studies. He's an outstanding mathematician. He's done a lot of very different things in many subjects, and they're all absolutely cutting-edge research, and he's someone that people really look up to in many subjects in mathematics. Certainly, his work on pseudo-randomness has been very influential.
Part of Jean Bourgain's job is to mentor postdoctorate research fellows.
I got in the mail Kahn's collected works. We need to interact with these postdocs, try to help them when they are stuck.
He's fantastic. He's just very nice and very easy to talk to. And maybe there are people who have never approached him before, and so just by reputation alone, they sort of are afraid of him. I could see that happening. He's one of the 21st century absolute giants in mathematics.
Bourgain owes his success to what mathematics has taught him from a young age.
First I learned hard work, because this is unavoidable. No matter whether you are smart or not smart, in mathematics you are not going to leave a mark without a lot of hard work.